Okay, so we start this part. Last week we already finished until a division, then I'll continue on for this part. We have this aggregate operation. It's more towards doing some kind of, let's say, function, aggregate function, count, sum, average, minimum, maximum, and etc. So we already have this relation. Let's say we can select all the attributes from the table. But now what we want to do is we want to do some kind of a summary. Okay, so we apply this aggregate function list, or shortcut we say AL, aggregate function list, shortcut AL. Then we apply this AL to our relation, and we hope that it can have some kind of a summary. Let's say we have a count, sum, average, minimum, maximum here. So we start asking some questions. Let's see who can I ask. Dongling. Dongling. Not here. Dongling. Dongling. Join and run away. Kai-Shen. Kai-Shen. Kai-Shen, we have this aggregate operation here, and you can see we have a count, sum, average, minimum, maximum. We apply this aggregate function to our relation. So normally, what do you think? Why you want to have this count, sum, average, minimum, maximum apply to our existing relation? What is the usage or purpose of having this? It didn't have any notes in our PowerPoint. You just think it. Yes, I guess. Calculate. Yes, calculate salary. Yes, we have a sample here to calculate salary. But why you want to calculate salary? The main point is why. Why we want to have this aggregate function rather than just doing calculate salary. We can simply count. We can simply count after we run the report. We can copy down and then use Excel to do the calculation. So why we want to do this aggregate count function? Other friend is welcome to help. Easier to do it inside. Actually, it's much more harder. You can see if we have Excel, right? We can just simply do the changes. If we have a one list here, we can simply put it back here, say, okay, well, I want to sum, then sum. If I want to do others, I can just simply do the changes. I already have all the data here, so that I can just simply click. Okay, so it is not easier than others. So it won't be easier than Excel. We know Excel is already very powerful. How? No? Okay, it's okay. Okay, thank you, Kai-Shen. Thank you, Hong Kong. Okay, so we have this aggregate operation, and if we need to copy and paste to Excel, then do the calculation. Of course, it takes more time. It takes more time, and then it's more what we say, it's not complicated, but too many work to do. But if we can just run this aggregate function and get the report, it's much more one step. We say one step. It's actually more complicated if compared to using Excel. Okay, so we can see we have this example here. We find the number of manager and sum of their salary. So we have a count how many staff here, and we also can sum out the salary here. And we even can specify the position we only want to know is manager. Okay, so this one is some kind of analysis. So a lot of this decision making by higher authority or the manager or even the CEO is more towards analysis. So Oracle or this database act as advice to the branch or to the CEO, to the director, making their decision. So commonly it's used to generate report and help them to make a decision. So that's why we have this aggregate function built into this Oracle rather than copy it out to Excel and only populate the data. Of course, a lot of these decisions they still are trying to use Excel. Okay, so this one is some example. So we can see here we have a count how many staff. So we have an answer here. We have 2, and we also can sum all the salary. So although we only have 2 manager here, we sum the manager salary. So we can see we have 54,000 here. If this one is in UK, means 54 pounds. 54,000 pounds. It means quite a lot, times 4, I think times 4.7 if I convert to Malaysian ringgit. So you can see we have 54,000 pounds divided by 2. Everyone is around 27. Yeah, 27. So it means the salary that they get is quite high. Now I say 27,000 pounds for them is not high, for us is quite high. Okay, so this one is the analyst. We can just run the script and get the report. Of course, the code that you write, you need to have basic. Okay, and make sure that you're getting the correct answer. So you need to do 2 times. If we can copy the data out and put into Excel, of course we know, okay, so the first one is 27,000, the second one also 27,000, of course total is 57,000. So then we can know, okay, so this one total is 54. So we know exactly what this number is get from. But for Oracle, you need to try first, okay? You need to try the script, see whether it's correct or not. Okay, so we already have this sample. We can use SQL to do the count, to do the sum, and we even can give it a specific group. So let's say it's the position manager. So this one is using aggregate function list. So another example of this aggregate function is calculate how many of property costs more than 3,500 pounds per month to rent. So we have this question here. Sorry. Chin. Okay, Chin, can you based on this question, how many property cost more than 3,350 pounds per month? Based on this, can you write SQL for this part? Chin, do you understand my question? Clear? Okay, select account property number from property for rent table. Yes, correct. Then next one is where the rent is greater than 250. Okay, good. Select account property number. You missed out one part here. It's okay. It's my fault. I didn't show you this. Okay, so the table, the result show out. I want to show this my count. Okay, so you should have as my count. Okay. Okay, so we have one example here using the count. So the result come out will have 1, 2, 3, 4, 5. Okay, because that is 350 is equal, so equal to 350, so it's not greater than 350. So we only have a 5 record here. Okay, so this one good. Thank you, Chinzi. Okay, so we continue to the next part here. So we already have this aggregate function list, and now for SQL, for SQL, yes, for SQL, we have a few more technique or functions that help us to do this kind of analysis. So this one is what we call grouping or operation. So we group these tuplets of a relation together based on its attribute. So we have this GA here, so shortcut say GA, and then we apply this aggregate function list AL to define a new relation. So we already have the relation, and now we want to group some tuplets together. So let's say previously we have a manager, then we can group it using the position. Okay, so we know it's manager, but the manager only is one of the position in the position attribute. So if we want to group others, so let's say if you want to get the result for others, let's say staff, clerk, or tele marketing, all these other tasks, then what we need to do is we need to run a few times using this query, and we need to continue change out the position. So for manager to staff to clerk or whatever. Okay, so this one is not reasonable. So what we need to do is we try to do the changes here, group based on the position. So if the position is manager, then they will group together. Okay, so AR will contain one or more aggregate functions. Okay, so based on this, we can get result based on a different group. So the result relation contain the grouping attribute, so group by position, then this GA will be position. Okay, so along with the result, each of the aggregate function goes. So based on, let's say we want to sum all the salary, then we can group it based on a position. So manager will have a salary, total salary of 54,000, then staff will be of course much more. Okay, so this one is some sample. Okay, example of this, we have find the number of staff working in branch and sum of their salary. Okay, so we have the first staff table. We also have another one on the branch table. Okay, so the first one here, we want to find the number of staff working in each branch. So for all the staff here, we want to group it by the branch number and then sum their salary together. Okay, so this one is the thing that I need to do. Find the number, then I need to count one by one. Count how many staff in one branch, then sum the salary. Okay, so you can see from here, we have a branch number of staff inside, and the total of a salary. Okay, so based on the linking to the branch, we can get this result. So the query here, we find the number of staff, we find the number of staff, and set the title as my count, and their total salary. Okay, so this one is the SQL. So based on different branch number, we can differentiate it using this way. So it grouped by branch number. Of course, the last part order is for us, easy to read. Okay, so not only we can count, we can sum the salary, but a lot of times we can even do the average or checking the maximum or minimum salary for each branch. Then maybe this one can be as decision making as well. Okay, so this one is the second one for today part, grouping. Okay, next one here we have this query optimization. Okay, you can see from the title here, we have a basic step in query processing. So it tells you step by step from this picture. When we write a query, so let's say this time we have this query, select a branch number, count sum from sub group by branch number, order by branch number. We already write the query, and this query is a pass. When we enter, it actually a pass to this parser and a translator. And from here, we actually do the first thing, translate into internal form. So for query optimization, not only for Oracle or Sim, one kind of a DBNF, but for most of our others, they're actually doing the same thing. See whether they can try to optimize it or not. Okay, so but of course, a different DBNF, the optimizer will be different, but the process of doing this is more or less the same. Okay, so SQL, after we enter, we pass it to the parser and the translator. So in this form, different DBNF, you will have a different kind of a language that is letting them to go through. So a lot of times when we learn the code, the SQL code for Oracle, when we go to, let's say, MySQL, to then some of the syntax may be different. Okay, so it will do the checking and try to translate into the internal form. So if it is running using Oracle, of course, translate into the Oracle part of syntax. Okay, then the next one is checking the syntax, see whether correct or not, whether there is any relation attribute, validate the relation attribute, and see whether it passed through or not. Before this SQL is actually execute, this type actually do the checking, see whether the syntax match all the data file or not. Okay, so before you actually do the optimization, so it eliminates the problem of when execute until halfway, some of the code is actually not matching the data file. So let's say the name of attribute, you cannot find this attribute in the database. Then what for we run this SQL, right? Okay, so by this, before we actually go through the optimization, do the checking, validate all the attributes first. So let's say we want to select the branch number. If a branch number not even there, then this SQL won't be executable. Okay, so this one is the checking for this part. It do the checking first before you actually pass to the optimizer. Okay, then the next part here is from parser tree translate to the relational. From the parser tree translate to the relational algebra. Then from this part, it makes it like algebra. So let's say what we have later. Okay, we will mention this the algebra, different type of algebra later. Then it will pass it to the optimizer. So this part, it will get something from the statistics. See whether this kind of SQL, the relational algebra run before or not. If yes, get advice, see which one can run faster, minimize and the resources if possible. So it will have some statistic checking. So if there is no such thing before, no such SQL before, then it will go through a list of testing before you actually do the execution. And so until this, we mentioned until this part, others we'll mention later. So we go to another one. So the activity of choosing a different execution plan for here, execution plan, for the optimizer, they do go through all the possible algebra. See which one is better. Okay, so that is what we call query optimization. So the main task of the optimizer. So it will choose the best one, the best algebra, then pass it to the execution plan to go through and see which one can run faster. Okay, as again, many are equivalent transformation of a same high-level query. Okay, so you can again you can see this keyword high-level query. Okay, previously I think I mentioned before our SQL database. SQL is a very high-level language compared to others. Let's say C, Java. Java is OO, but for this query, it's much more equivalent to human being communication way of a language. Okay, so it is high level. So when we translate this into machine language, it actually needs some kind of a translator. Okay, so translate, then continue the process again. Okay, the aim of this is actually try to have this query optimization. Okay, so the main task here, minimize the resources used. So what is the resources we're talking about? Is generally refer to the execution time. So the time that I need to run this query, then will be much more better. Okay, so previously if the resources is not enough, we say the resources is not enough. We have tried to talk about the CPU and the RAM. This kind of resources is not enough for us. It is possible. When we run this Oracle in our computer, it takes about 1 gig to 2 gig of memory. So if your computer is only, let's say, 4 gig RAM, then if you install and run Oracle, you will feel the pain of low memory. Okay, so all those Oracle, when we do the installation, it recommends 4 gig or more, or 8 gig or more. But if you install Oracle in your computer, which is only have a 4 gig, then the execution time is actually a little bit slow. It needs to have it needs the process of a transfer of this memory to a temporary, let's say, swap file, and later swap it back again. Okay, so this one is what we call minimize the resources used. For us, it is possible that we will face this problem: CPU, RAM, then the hard disk space. Okay, so if the memory is not enough, it may transfer or swap this memory, the usage to temporary file. Then after finish execute the query, then transfer it back again. Okay, so the time of read write to this is actually quite a lot. Okay, so this part they will try to minimize the resources used. But if your computer RAM and CPU is good enough, then you won't feel it. You won't feel it, but you will feel how long it takes to execute one SQL. It's mainly the time, okay, not the resources of a CPU or memory. Okay, so this part I think should be okay. Then we can continue giving some example why we want to have this query optimization. Okay, so you can see from here we have one query. This one family. Select all from sub X, then a branch B, and then the branch number is equal to branch number, and we want to select only the position equal to manager. the city is equal to London. Okay, it seems like quite reasonable, right? We only want to know some people like London, B005 and B002. So B005, B005. So we can get this John White and Julia Lee easily. Okay, so based on our human being, our eye try to find these two, and it seems like not difficult. But for our query for Oracle, if we want to go through this simple query, it actually go through a lot of this decision making, what we call decision making. So you can see from here, for example, okay, we have this three equivalent RA here. Even we have we only have a one SQL, but when we pass this query to the DBMS, it actually go through a lot of process. And for the relational algebra expression, it do change it to a few times, then send it to the optimizer. See which one is much more easy to execute and how long it will take. If it has some statistics from the data, then if you know, I think this one is the faster one, then you will execute the faster one. Okay, so this one is let you know, even one query, it may have few RA. Okay, so different RA may use a different time and a different resources. So we just do some assumption here. We assume that the table here we will have a 1,000 tuples in the start table, and we have a 50 tuples in the branch table. And based on this start table, 50 of the 1,000 is manager, and 5 inside of this 50 tuples in the branch is in London. Okay, so this one is the assumption. And what we need to know here is for this practice, the optimizer, it actually have this thing called tuples are accessed one at a time. It checks one tuples at a time. Let's say we have a 1,000 tuples in the start table. It actually go to 1,000 times. Okay, same thing for the branch. It go to 50 times. Okay, so each tubelet it go to one at a time. So it ignore the possible of running this query using hyperthreading or using different core of processing. Okay, so it go through one by one. Then based on this assumption, we actually have the result here. Say result of intermediate operation stored on the list. So we get 50 major from this tuplet. Then we save it to the list to the hard disk. We check and get 5 London branch. Then we save it to the list. Then I read from here again and continue all others query. Okay, so this one is what we call the intermediate operation. After you get the result, we save it, then we run others query again. Okay, so this one is the idea. So we based on this idea, we do a compare of the RA, see which one run faster. Okay, so for the first one here, different RA, the time need to the process, each of these process read write from the list from the disk, and until the ending of this SQL, it needs I think of 10 million. This 1,000, yeah, 10 million. Okay, so the process, the operation is around 10 million. The next one here is only a 3,000 pass, and the last one here, which is the most faster one, only 1,000. Okay, so you can see it is only a 10% of the most difficult, longer time the comparison. Okay, so based on the different RA, the time that need to execute is totally different. So how are we going to get this number? So for the first one, we have 1,000 staff, so it read 1,000 staff. We have 50 branches, so we have read 50 branches here. So based on these two, we write the record 10,000 times 50 record to the disk, and then we read another one again, 10,000 times 50 to the to search. We write and then we search again. Okay, so based on this number, we do the searching again. So continue doing this, and the time that I need to go through is a lot. The second one here, we have this read 1,000 stuff, read 50 branches. Then we try to do a join, and this join, the number is around 50 times 50 times. We have how many? 50 times 5. Yeah, it should be only 250. Okay, we join this result based on 1,000 row, try to join it to the branch data 50. Then we only do the write and read. Okay, so the time of doing this is only 3,000 pass. Okay, the last one here we have a read 1,000 staff, write 50 manager, read 50 branches, write 5 branch. Then the last part, we try to do the final join, 250 join, and only we write it to the list. Okay, so of course the time of doing this is much more less compared to others. Okay, so the previous few slides telling us using a different RA actually have a different time consumed, and this is the concern of the optimizer. It will need to check which one is faster. So previously I mentioned if this query didn't run before, it actually go through each until it find that okay, this one is faster, then it will execute this one. Okay, so it do the analysis evaluation and see whether which one is faster. Of course, you may need to read and write first, then after you know which one is faster. So it will go through one round, then save it to the statistics, and based on the statistics, next time it will know which one is faster. Okay, so this one is optimizer. Then I'll continue our evaluation of this expression. So previously we said materialization. Every time when we finish searching the result, we set it to this. And only continue do under the process. Okay, so this one is called materialization. So evaluate one operation at a time. We start at the lowest level. So we search everything first. We search all the things from the row. Then we use the intermediate result materialize in a temporary relation. So we stick to the disk, then only we get this result and try to evaluate the next level of operation. So that's how we have one example here. We search all the stuff. We search all the cities. we get already, we set it to the this, then only we try to do the matching, joining, analysis, whatever. Okay, so this one is what we call materialization. Okay, generating and saving a temporary file to the disk is time consuming. Okay, so previously when we didn't have this SSD, if you play in our lab before, if our lab PC start, it takes a lot of time to do the updating. If the internet connection is there, it takes a lot of time to do the updating, and the disk processing is nearly 100%. So compare the hard disk, the mechanical hard disk, and our SSD. Of course, the timing need to run is I think at least 70% more, or even nearly 80% faster than the mechanical hard disk. Okay, so for most of the database, we actually are still using the mechanical one. Okay, previously so the part of generating and saving a temporary file to the disk is actually quite long time. Although we say it should be very fast for most of the supercomputer or whatever, it should be very fast, but it still need to take a lot of time compared to the SSD. So this one is actually quite expensive. So we come up with another idea. So we have this pipeline. So the evaluate several operations simultaneously. We try to do several things in one time, and if one of the results is already produced, and then it will transfer this to another process. So based on the existing or the result, then it will try to reduce the time for other operations as well. So evaluate several operations simultaneously and pass the result. So the main point here is to pass the result to other blocks or the next operation. So it will try to reduce the other operation as well. At the same time, it didn't save the result to the disk. So this one reduce the saving temporary file on this process. So it reduces the time as well. So avoid constructing a temporary result. So it's possible. So this one we already mentioned. If the RAM CPU is good enough for the database, it will try everything in memory rather than save it to the disk. But if the RAM is not enough anymore, then we will have a lot of this saving to the disk operation. Okay, also known as string-based or on-the-fly processing. So you can see the picture here. For materialization, we have this order detail here. So it do the process for customer and for order, also the same. It compute, okay, it compute and try to join, compute, and then try to join. Okay, so it join to materialize the relation and only a project to the scene. So each individual process, it run, save to this, run, save to this, join together. Same thing here, run, save to this, and only join together and produce this scene. Okay, so for this part, of course, it takes 1 time, 2 times, 3 times. The time of saving is much more than doing the process. For the pipeline, it try to do this thing. Once a row of order detail satisfy the selection or condition has been found, it will just pass here. So pass it to the join, then the join will start doing the search rather than save it to the disk. Okay, so don't store the result, but we try to join and then pass it to no, not join, but try to pass it directly to the projection. So the searching part here, if we already have an individual record, based on this individual record, we can continue searching here. So it already reduced the time of searching. We reduce the time of getting the result. So only those orders that already are priced greater than 5,000 people get from this join. Okay, so this one will reduce the time of save to this, and again reduce the time to filter getting result from this part. It still will go through all the tuplets, but we already update the query, the condition. Okay, so 350. Okay, we rest 5 minutes here. Then I'll come back, we start this exercise. Before you go, put a +1. Okay, we have one exercise here. Just try Some is easy, some don't know how to do. Okay, so this type, I will assign some student to do it. And if you already see your name, can you put your number here? So let's say Ping Ping, can you put a one here? Yang Ping, put a two here. Wei Rong, put a three here. Kaiman, put a four. Wei Tiao, five. Xuan Ni, six. Chun Kiat, seven. Pei Si, eight. Zilok, nine. So afraid some didn't assign. Okay, Pei Si, one, two, three, four, five, six. Xuan Ni, six. Xuan Ni is not here. Okay, Xuan Ni not here. Chun Kiat, Pei Si, Zilok. Dewey, Dewey also not here. Dewey, Xingran. Okay, this one I change to Xingran. I think I should change it. Hmm. Okay, so if I already have a result, can send to chat room. Then I'll be show one by one, see whether it works. Thinking your one is too easy. Maybe I should assign you another one. In case you may need to refer to this one. All the attributes have the name and they have a relationship. So I'm remove your answer first. Chirot, Chirot. Okay. And before we go, we actually have show this. Okay, I remove your answer as well. You try to think first. We have a keyword report. Produce a report, not only a select. Okay, for those who didn't do any task here, can you help to verify whether the answer is correct or not? I didn't have a sample answer here, but you just simply go through see whether it works or not. If the answer is not correct, then maybe we need to discuss. If everyone thinks the answer is correct, then we can pass to the second question. Kaiman, you may need to refine your answer. For my book copy, there is no book title inside. Kaiman, okay. Xing Rang. Is the Xing Rang still here? Oh, I should have asked this question 6 to everyone. This one seems like a little bit difficult than others. Xing Rang still need to check again. And everyone, question 6. This question 6 seems like we haven't get the clue yet. Because it mentioned still borrow, but Xing Rang here say is the date out is less than current time, but it didn't mention whether it is still up or not. Okay, so Xing Rang, no response. Question 6, we still need to do some changes. But I think others also need to help. You need to think we still have something missing. Can I update question 4? Maybe the all students may need to check again. This is question 4. Chilok, your answer. Chilok, you seldom borrow book from a library. Date out is the date that you borrow the book. Normally for me, it's 7 days or 14 days. So let's say today I borrow the book, the due date is 14 days after this date out. So it won't be using a different to do the checking. The date out won't be possible greater than a date due. So check again. For this part, it seems like not reasonable. Okay. Okay, Xing Rang, change answer. Xing Rang. Xing Rang. Another one. Xing Rang, I think we have the same problem for Chulok. Xing Rang. Chulok say date out greater than date due. This one won't be possible. Same thing for your one. The date out won't be, yes, date out is less than current time. Sorry, my mistake. Date out. But your changes seems like didn't update anything, right? Same one, I still wait for your answer. And the way condition, way tighter, right? Way tighter, equal to log of 7, yes. And D date out. Okay. Way tighter. I mean number 7. Oh, okay. Sorry, Chunki, I talked to, at the time I talked to Xing Rang, I say there is no changes from the previous one until now. Sorry. So I check again. Question 7. Chunki, the problem is not the current time or now. It's okay, I haven't touched that part yet. But the comparison of attribute is not correct. We say this part, right, date due. Date due is less than due. Chunki, I just go through this part again. For the date deal, I repeat again. When let's say today is 20, let's say today is 1st of February, I go to borrow a book. And normally my return, I can borrow the book for 14 days. So it means 15, the due date of my book is, the due date is 15th of February. So the due date, date due or due date, it's preset. So for this part, it asks us to check those books that still overdue, means it's already past this date due and haven't returned yet. But here there is nothing mentioned about whether it returned or not. Date due is at the time, but whether it returned the book already, there is no such thing here, right? Okay. So other students, this kind of exercise is helping us to think the SQL, how we're going to link all the table attributes together and see whether it works or not. We won't, I didn't have the sample answer, but we just sorry, I didn't have the sample answer, but when we go through and we see which part got problem, then we just do some minor changes. So if the comparison of the attribute is correct, then we can simply pass through. But the attribute to do the main task, to do the comparison is not there, then we may need to think. But and other students can help see which one can add to the SQL, then maybe you can solve the problem. Okay, here this Peter Bloomfield is not included. Okay, while waiting others to think, we just simply go through first few one, see whether I'll pass through or not. If I pass, then we put a remark, blue color. So we list all the book titles, so select title from book. This one should be okay, huh? So we have a book title. This question is too easy for thinking. Okay, another one is Jiangqing. We select all, we list all the borrower details. So we have a one table called borrower, and we have a borrower number, borrower name, borrower address. So Jiangqing just show everything, but we can actually put star here. So select all from a borrower. So this one doing extra lah, doing extra. Okay, so it should be okay. The answer still the answer still no, the result still the same. Okay, we produce the same result, so it should be okay. Okay, list all the book titles published in year 2019. Title. Okay, year 2019. Okay, so for this year, this one is quite complicated. It seems like we cannot just simply say year 2019 because sometimes the published date can be 1st of January until 31st of December. It won't be just simple put Vacha 2019, but this one is minor problem. So we just put do the changes until this part. For the date part, within certain time period, so this one we do the changes here. Okay, so this one question mark, you have a question mark. See which one is correct. Okay, so the next one here we list all the copy of a book title that are available for borrowing. Okay, for Simon, question 4, this answer here, the book copy, select ISBN from a book copy where available equal to yes. Of course, this part is correct. And for Singrang and for Chunkiet answer, you may need to think about this available. Okay, so we have the question here say want to list all the book title that is available for borrow. So we Simon answer here, select all from the book and then the ISBN. So if we refer back to the picture here, we select from book and then the ISBN a link to book copy and this book is available. But the main point here is the linking is between a book ISBN and book copy ISBN. But there is no such thing. It should do the comparison, then check whether this copy number is available or not. Okay, so I think this answer we still have something to check. We should link this ISBN together, but the compare is still in the copy number. Okay, so this one we research first. If any other student have a suggest answer for question 4, start from where the condition, it seems like not so matching to the available of the book. Okay, so whether answer seems correct, and we can do some changes to this part as well. So borrow we tell answer, but just remove a lot of the ring. Okay, do you use it before? Do you during a lecture class or during a practical class? Okay, so until question 5 should be okay. Okay. Because previously for this kind of question, right, we just simply give an answer then discuss. No one thinking about changing from PowerPoint to Google Doc. So I didn't think about this. Thank you. Next time I will check again and see how to use it. Okay. So question 6. Singrang, do you change anything here? This part still did out less than the current time is still not so correct. We have available equal to no here. This one seems like more reasonable. Singrang, you may need to check again. This available equal to yes or no, 1 or 0. We actually do not know what the data type of this variable. Maybe it's yes or no or 1 or 0. Okay. So I think at this part you need to check. Question 7 I think should be okay. We already have this BC available equal to now. Less than now. Okay. So 7 should be okay. Number 6 is still written for Singrang. And Tracy already updated this. The last part here, say borrower name equal to Peter Bonefield. So this one okay. Actually, Tracy, do we really need to link all this together? Okay. Okay. So we only left 6 and 9, which is haven't finished. But we also didn't have this table or data to test whether correct or not. But the idea is already there. Hopefully, we have the correct idea to do the checking for this part. So Singrang and Sulok, we still waiting for this one. If you can, then just do it. Okay, so for question 8 and 9, it's a little bit different. You can see for the previous few answer here, we actually are showing list the name, list all copy, list the name, whatever. But 8 and 9 is a little bit different. So what is the difference here is, based on my understanding, when we want to show a report, we still need to go back to what we have here. So we try to do some kind of a grouping, some kind of a aggregate function list, try to do the checking, maybe need to show some count, then this is what we call report. So basically, we not only show everything, then we say this one is report, but for report, normally we have this aggregate function list, or even we have this grouping operation. So you can group and try to show something that is, how to say, more meaningful to the one who read this report. Okay. This chapter, the last part here, exercise is quite challenging. I hope everyone can learn something from this part. So not only those that contribute their thinking to the exercise, but other students try. Okay, try. So if you have any suggested answer, let me know. Maybe to WhatsApp, or even you can list it down and show us the next time. Okay, so Singbang and Sulok, do you want to show something? Or if no, then we'll end here. No idea. You still need to think about this. Available equal to yes or no. If the available is yes, means it's already written. If the available is still no, means it haven't written. Okay, so it's overdue. At the same time, the date due is already less than current time. Right? Understand? You need to use this available, and this you may need to change it to date due rather than date out. Okay. Same thing for Sulok, I think. You still are missing one available. Date out. No. Date due less than current. I think your answer here, the current time stamp is good. So don't need to worry about this. But this one, you need to change it to date due. Yeah, change it to this one. Okay. Sulok. Oh, Sulok part is missing available. The library system didn't have a check, see whether there's any overdue or not. But we need to run through some of the script here. It's already past the due date, so we do a comparison. Date due is already a less than current time system. But at the same time, you haven't returned the book. So whether you return the book or you haven't returned the book, the determination is the available. Okay, so if the available is yes, then of course you already returned the book, so no problem, it is not overdue. But if the available is still no, then it's overdue. So Chunki already finished this part. So you can see this is date due now. So this one is overdue. So you can refer to this. Okay, so Singrang and Sulok, we wait for you next lecture to update us the answer. So if no problem, then we end here today, and see you again during our practical class. And I need to mention this. Previous practical class are from 2 to 4. All our students bring their own laptop. So until now, I still haven't had the chance to test if you use our lab PC. Do you able to copy this database back to your own computer? So we haven't tried this yet. So it will be good if you have your own laptop, bring your own laptop, and don't forget to bring the adapter. Okay, you have a friend, forget to bring the adapter. Okay, so if you want to join our practical class, face-to-face practical class in the campus, please try to bring your own laptop and remember to bring adapter. Okay, if no problem, no question, we end here today. Okay.